Hello, check this out. Oops. Well, you can see what I'm doing there. I'm using my cheap-ass transmitter, which is connected to this Orange RX receiver, which is connected to an Arduino Uno, which is connected to the computer. And the game that I'm playing there is called FPV Freerider. I'll put a link to all the stuff in the description below. But originally what sort of got me started thinking about this kind of thing is that I got the Dirt Rally game, which is out on early access on Steam a couple of months ago. And this game is really quite impressive. I've played most of the Dirt games over the course of their history, way back to Colin McRae Rally in the year 2000, I think that came out. But this one is very nice graphics and everything, and very good simulation and sound and everything. So I wanted to play it, and the way I played the old games was just by using the keyboard and doing the old PWM pulse width modulation for turning, using the arrow keys to turn. But it works all right. I managed to get through the original Colin McRae, the whole game like that, but it's just not the same as using a controller. So first thing I tried was using my cheap Xbox clone controller. I got this for about $15, but there are some nasty deadbands in there, so even though you do have analog control, it doesn't start until you get sort of a little bit away from the center, and then it sort of suddenly turns the steering one way quite quickly, which is a bit hard to control, and also with the throttle and the brake. So I was using these two analog sticks to get better control than the keyboard tapping. So it worked better than the keyboard most of the time, but still wasn't quite as good as these joysticks that we have in our RC transmitters, because they have no deadband pretty much and much smoother control. So I wanted to do something like this. By the way, I found that having these smoother RC joysticks, it didn't really help a lot in the situations where you're wrenching the steering from side to side very quickly, like in this slippery section of gravel course here. But it did help a lot in like tarmac courses, which, especially like this Pikes Peak hill climb, which are straighter and faster, and you can really feel the difference when you have a more precise steering control. But in either case, it's a much nicer experience than either the keyboard or the regular Xbox controller thing. Anyway, back to the story. At that point I just sort of gave up, because I went back to using the keyboard for the rally game, because it worked alright. But then I discovered the FPV Freerider game, and I thought to myself, well, now I really do want to use this for controlling the game. So I had another look around on Google, and I found something that I missed earlier, and that was the UnoJoy project. So this is the homepage of the UnoJoy project, and as you can see, it says UnoJoy lets you take a regular Arduino Uno and turn it into a native USB game controller. And as far as I know, you can do this with an Uno or a Mega or a Leonardo at least, but you cannot do it with a Pro Mini or a Arduino Nano, because what it involves is, as well as programming the main 328P chip on the Arduino that you normally program to upload your sketches and stuff, we also have to program or upload some firmware into this other chip over here to make the Arduino tell the computer that it's a gamepad or a joystick or something else. So just to have a closer look at that, that's this chip here, and on the Arduino that I have, at least, it is a Mega 16U2. So this is the chip that when you connect it to the USB on your computer, it says, "Hello, I'm an Arduino Uno." But what we can do is overwrite the program inside here to say, "Hello, I'm a gamepad," or a joystick, or something else. So there's a few different steps involved in doing this, but hopefully if you see me doing it, you'll see that it's not so hard. At least I find that anyway. When I'm reading documentation, I think, oh geez, there's so many steps here. But if you just see somebody doing it, then it doesn't look so bad. So hopefully that's what this video is going to achieve. So the way we program this is we have to short these two pins here briefly, and that will put the Arduino into a mode called DFU, Device Firmware Update mode, and then we can upload hex files onto here. So if I just how should we start this? First, let's have a look at what you're going to need to do this, because I kind of skipped over one important point, and that is that, at least to use the sketches that I've made available, you'll need a receiver that is capable of ppm output, ppm sum output. So that means you're just going to have 3 wires only coming from one of the sets of pins on your receiver to the Arduino, or what would normally be your flight controller. And you will need, of course, an Arduino Uno. One thing I noticed when I was looking at the information for this on the Arduino website is that it says here, if your board is not an Arduino Uno surface mount device, so that means if you have one of these big long chips on here instead of the SMD, like is normally on the little square one like that. So this applies to my case, I would have thought. It says you'll need to solder a 10K resistor brown, black, orange on the back of your board here. However, I found that I did not need to do that, but I should also mention that when I look at the back of my board, it doesn't look like that, and I can't find these little pins. The layout is slightly different, so perhaps this board here is not a revision 3. Does it say on there? I don't know if it says. But if you have a revision 3 board, you might be able to get away with not having that resistor on there. Apart from that, you will also find it handy to have some little wires like that. Right, so the first thing that I think it would be a very good idea to do, it's not strictly necessary, but what I did was I made a sketch that doesn't do any of the UnoJoy stuff. All it does is check that your connection between the radio and the receiver is giving you the data that you expect to have. So I made that sketch here called ppmreader, and it just does a little bit of stuff. I pulled this out of the MultiWii source code actually, and it just lets you check by printing out the values that are coming in from the receiver, just to check that you've got everything centered and the axes are behaving as you like. So you can reorder the axes like this. I found that the channel 1 was pitch, channel 2 was yaw, and so on. So you can reorder this to get it how you like. I only have 5 channels, but if you want more than 5, you can change this number here, add another number up there, and then in this enum here you can add as many channels as you want, or as your radio has that you want to use. So all this sketch does is let you see, let's turn this on. So if you check in the serial monitor, you'll see a bunch of numbers printing out like that, and all it does is let you see what values the Arduino is getting from the receiver. And when the sticks are all centered, it should be about 1500 in each of those channels. Of course, the final one, the far right one, is my switch, so that's going to be always 1000 or 2000 roughly. And the extents of these should be about 1000 and 2000 when they're at their full extents. So that lets you see what values you're getting. And as well as letting you confirm that you're getting some sensible numbers coming through, it also, at least in my case, I wanted to adjust the values a little bit for each channel because I don't have any trims on my cheap-ass transmitter. Well, I have them, but they're not connected. They don't do anything. So if you want to trim your values in the program, you can do it here. Like I say, you may not need this if you have trims actually on your radio, so you can just take this section here and get rid of it and just return the diff value there, and then you can trim it on your radio instead. So that's all that program does, but I think it's a good idea to at least load this up on your Arduino once and confirm that you're getting some sensible readings from your receiver, rather than try and do everything all in one go, and later on you're going to be looking at a whole string of things that could be the problem. And speaking of string of things, the next thing that we need to get done is to get hold of the UnoJoy source code, and you can find that here. I think this is where I got it from. There's also some source code on GitHub, but if I remember correctly, I downloaded this one, and in either case, this is what I ended up with in my unzipped folder. And the important parts of this are, in this folder here you'll find a sketch that you can open with the Arduino IDE. So that's this one here, UnoJoy Arduino sample.ino. So you can open that with Arduino and compile it and upload it onto your Arduino. And the other thing that we're going to need is in this folder at the top here, ATmega8U2 code. I'm not sure why it's labeled that, because it has some other code in there as well. But inside here is a folder called hex files, and there's two very important hex files here. So these hex files are pre-compiled Arduino sketches. So if you remember from when we compile a Arduino sketch in our IDE, the last thing it does when it compiles is this command here, and the output here would be, for example, the ppmreader sketch that we were looking at just before would be something 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 dot hex. So it's a pre-compiled Arduino program. And where's my folder, was I in? Here. So this is pre-compiled, but it's not pre-compiled for the Arduino, it's pre-compiled for this thing, the little greeting chip on the Arduino there. So that's very important. So we've got two of them, and they are that one there, Arduino USB serial uno.hex, and this one down here called unojoy.hex. Now, depending on which one of these hexes we install into our Mega 16U2 chip on the Arduino, that will dictate what's going to happen when the computer connects to it. So you should be able to figure out that this one will turn it into an ordinary Arduino, and this one will turn it into a gamepad or joystick. So we're going to install those later on, but first up let's go back to the sample sketch there that we had. So that's this one, and if you open that with your Arduino IDE and have a look at it, you'll see something kind of like this. I have actually edited this one a little bit, but I'll just look at the main part of it here, which is a function called get controller data. And what that does is it does a whole bunch of digital reads. So we do digital read of pin 3, pin 4, 5, 6, 7, so on, and then at the end of that we do 4 analog reads. So what this is doing is it's looking at the state of all your digital pins along here, and then the analog pins over here, to check if you're pressing a button on the gamepad. And like I say, I've edited this one a little bit, and I have this variable called use ppm, and if we skip down the bottom here, we'll see that I've actually pasted in all of the code that we had in the previous sketch to do the ppm reading from the RC transmitter. So this variable here, use ppm, is at the top, and I've set that to false at the moment, so we're not going to use any ppm. So in this state, the sketch that I'm running, that I'm uploading now, will be pretty much the same as what you get when you compile this sketch straight out of the zip file. Right, so let's just check if we can compile that. Okay, and now we can let me just take this off for a moment, get out of the way. Why am I looking at this? I don't think we need to look at that. Hold on. Anyway, so I'll just upload this sketch to the Arduino Uno, and you can see the lights are kind of going there, and now we are ready, except this still thinks it's an Arduino Uno, and we have to change that to make it think that it's gamepad. So that's where those two hexes that we had looked at earlier are going to come into play. Now this is where things get a little bit different. I'm using Linux here because it's much easier for me to do all this recording stuff on Linux. I did try this on Windows as well, and it's pretty similar, but this next step is different. So these hexes that we have here, these two hexes, we can't use the ordinary Arduino IDE to upload those. We need to use something called a device firmware update programmer, and we need to put the Arduino into a state where it's ready to accept the device firmware update. So I'm going to do the Linux part of this now. You'll need to get another tool. Yep, another one. Where are my windows? There we go. Okay. Right, so there is a utility called DFU Programmer that you can get for, I don't know what source this would run on, but it looks like it's set up primarily for Linux. So this is the one that I've used. I did notice though that when I did yum install DFU Programmer, it's in the yum repository if you want to install that. However, when I installed that one, it did not have any support for the ATmega16UP, which is a bit of a bummer. And you can see that by when you run the program, it says you can do targets to see what it supports. So the one I have installed, which is the one I'm about to show you, is capable of talking to the ATmega16U2. And the one that I got from the yum repository, or the one that you may get from the apt get repository on Ubuntu, perhaps might not have this in it. So just check by running with this targets parameter, just to make sure that it has that available. But if it doesn't, you can get this source code. So all I did to do this was I downloaded that zip, and then I put it into this folder here, and then we cd into that folder, and it's the usual story of doing configure make. It's only small c, and then you can do make install, but I've already done that, so I don't really need to do it now. So how do we use that program to install those hexes that we had in our UnoJoy folders? Let's go into cd into, oops, change into that folder, and now we should have those two hexes in the current working directory. Okay, so we still need to set our hardware side here to be ready to accept that to be uploaded. So that's pretty simple. I usually just use a little metallic screwdriver or tweezers or something, and short across the two leftmost pins here on this set of 6 pins, and you'll see that when I do that, if I get it right, the LED will go off. The LED that's just to the right of this. So the LED's gone off there, and that means it's ready to accept updates to the this little chip there instead of the normal one. Okay, So what we can do now is we can do DFU programmer ATmega16U2 erase. So the first step you need to do is erase, and we should see a little bit of action on here, I think. Okay, and it's very quick. It just says it's erasing the flash memory. Success. So yeah, that's all there is to it. Now, to turn this into a joystick or gamepad, we need to do the same thing, but instead of doing erase, we're going to do flash, and in this case we're going to put the UnoJoy hex on there to make it into a gamepad. So once again, it's very quick. That's all that happens. Now when we shorted those two pins there to set it into the DFU state, it stays like that until it's reset, or at least probably until it resets. But to make sure that the computer accepts it as a gamepad, we need to physically disconnect it, I think. Not sure if reset only would do that. But now when I connect it on here, we should see, if we look at our device log, see the very last thing that happened here was there is a new device. So there's a USB human interface device, and it is a gamepad, and that's the type of it there, UnoJoy joystick. So on Windows, to do that, you would look at your device manager, and you should see one of the devices showing up as a UnoJoy joystick. I should mention at this point, I never saw that, but it still worked. So don't be too distressed if you don't see that showing up in your device manager when you do this at this point. Okay, so for Windows, as I said, that this part of the process is a little bit different. So how would you do that on Windows? Well, if we go to the UnoJoy main folder again, we'll see a couple of batch files here. One says turn into an Arduino, and this one says turn into a joystick. So I think you can see what you do there. You run one of those, whichever one you want. So instead of doing the DFU programmer step like I just did, you would use one of these batch files. However, on Windows you will also need to install, where are we? You'll also need to install this thing here. So if you go to the UnoJoy homepage again, you can see on the Getting Started page there's some info there about what I'm doing here, and somewhere on there you'll see a link to this page, which is the Atmel flip tool, and you can come over here and it says buy now, which got me worried for a moment, but I'm not sure why it says that, because if you go down here you can download these too. So you'll need one of these too if you're using Windows. The only difference is that one of them includes the Java runtime, but I think if you're running the Arduino IDE, you will already have the Java runtime installed, so you can just get that one there, I think. And then once that is installed, these two batch files should work. At least they worked for me. One thing to note though is these two batch files, they check for another type of chip as well. So we're using the Mega 16U2, but those batch files on Windows, they first check if there's another type, like a 9U2 or something like that, 90 or whatever, and it says failed. But then it checks for the 16U2 and it says success. So even if you see one line that says failed or error or something in these, when you run these, as long as one of the two sets of attempts works, then it should be alright. Okay, so at this point it's quite a good idea to check if the thing that you've got here is actually working properly as a gamepad. And I found the simplest way to do this was something that I came across when I was doing game programming last year, and that is a very, very good gamepad library written by this handsome gentleman called Themsall Took, and I found this in the TigSource game programming forums. and it's a cross-platform library that, among other things, has a test harness which lets you see what the inputs are doing on your gamepad. So if you come to this forum post here, and you can download this zip file, it's the latest binaries for all platforms, and I put that onto my hard disk here, and you'll see when you unzip it you'll have this folder, libstem gamepad, and inside the test harness folder you'll see a bunch of pre-built stuff, and I'm going to use, of course, Linux 64 because that's what I'm using at the moment, but you can use the Windows ones if you're using Windows. So when I run this, it just gives me a very simple display here, and it detects which USB gamepad devices are connected to your computer. And I only have one at the moment, but it should show more if you have other ones connected. And it'll show you the name there, so there, and the vendor ID and stuff like that. So at this point we should be expecting to have some buttons pressable, so that's where our little piece of wire comes in handy. And we just quickly go back to the UnoJoy source code. We see a little comment here that says since our buttons are all held high and pulled low when pressed, we use the not. So not digital read 2 and 3 and so on will cause the buttons to be pressed. So that means that we need to pull these pins low to get a button to be pressed. So I'm going to put one end of this into the ground pin on the Arduino. That's ground. And with the other end I'm going to try bringing these other pins low. So let's start with pin 2. So that's given us button 3, and you'll see that as I move along here I can press buttons, or they, not really buttons, but effectively it's a button. Why isn't that doing anything? Oh, this one is a D-pad, so you can see A5, which is the D-pad, so that is actually a button. It's behaving as an axis, but that's this thing here. For the unfamiliar with game controllers, that's this thing here. It's actually 4 individual buttons, but it registers on the test harness as an axis. So you can see when I touch on here, the analog inputs are floating, so they're just sort of picking up whatever voltage my hand is giving to them. So anyway, yeah, that's how you can press the buttons, and you should see those little green squares lighting up like that, and if so, then everything's working. Just to clarify, the analog is not supposed to be like that. Normally you would have some analog thing on there like this. So if I put a simple dial on here, let's try, it should be analog 0, this one is ground, and this one is 5 volts. Okay, so I've just connected this to analog 0, and now you should see the, well, it should only be one of them really, but I noticed that when the other analog pins are floating, they'll follow whichever one of them has some actual input. So all 4 of the analog inputs are moving in this case. Obviously you wouldn't be doing that for real when you're doing something, so if I just ground, the other analogs there, you'll see now we have only analog 0 doing what we wanted. Right, so if you wanted to make a non-wireless game controller without using this fancy, RC controller and a wireless, receiver and everything, you could just set up a bunch of analog things like this. And I think I might actually try this for the driving game. I haven't tried it yet, but this would be a little bit more natural for turning a steering wheel, I think. So I might try that after this. But getting back to our wireless system, let's take that off and take that off and take that off. So I'm going to put the receiver back on here. Okay, so the receiver is back on there as it was before. And I'm going to close that test harness because we've checked that everything's alright. Now if we go into the ppm UnoJoy, and this time I'm going to say true to using ppm. So instead of reading the analog input from the instead of using the analog inputs on this Arduino itself, we're going to use whatever's coming from the radio as we had in the first set of first sketch. Now uploading this is not going to work at this point because, remember, this is not an Arduino now, it's a gamepad. So to change the sketch we need to revert the Uno back to being a real Uno, and we can do that by, of course, doing erase, and once again we need to just quickly short those two pins. So you can see the LEDs going crazy sending information to the computer, and when I short the pins it stops. So it's just a visual indicator to make sure that you've got that shorting part right. Now I can do erase, and this time I want to flash Arduino. Let's make that a bit wider. So flashing the Arduino USB serial uno.hex will return this to being an Arduino Uno, and of course once again we have to disconnect and reconnect it so that the computer picks that up properly. So now we have an Arduino Uno that's arrived. So now we should be able to upload that sketch properly. Okay, done uploading, and then back again to this. So you're going to find yourself doing this over and over if you change the sketch. So once more I short the pins, erase, and we're going back to UnoJoy, unplug, reconnect. Alright, now let's look at the test harness, see what that's telling us this time. Okay, so we have this on here again. Now we can see that 3 of the analog channels are in the center approximately, and one of them is at 0. Now I don't have the radio turned on, so what this is the failsafe settings of this receiver. It's setting the throttle to 0. So that second channel is the throttle. And if I turn the radio on, we should see now all of these first 4 analog channels are going to be following my radio receiver inputs like this. Pretty neat, huh? So from that point we can set up the FPV FreeRider games. Kind of the main focus of this video is I think most people watching it will be interested in setting up the FPV FreeRider game, but I will do a little bit of the Dirt Rally game after this on Windows. Okay, I have the FreeRider game in this folder here, and if I start it up we'll see made with Unity, and then you'll need to have this set to USB controller, of course. I have this at throttle 0 at bottom and dead zone off, and then if you click calibrate controller here, if you're anything like me, you'll waste 2 hours trying to figure out what the hell is going on. So hopefully I'm going to save somebody some time by that next little tip. Close the program, put the throttle, or all the sticks, to the middle point. Now start the program again. For some reason it looks at the throttle position on startup, even though calibration is not being done or anything. Really, really annoying. I hope that is changed later, because it means that every time you need to get the throttle position exactly where you had it last time, otherwise your setting is going to be screwed. Anyway, so now if we start the program, we should see. Oh, cool. Alright. Hopefully that is on the screen. Now if we do calibrate controller now, we should see those 4 inputs there moving. Let me just put this here maybe. Alright, that might be a bit easier to see. Okay, so those 4 inputs are moving there and we can see which channel is which and so on. So the way this works is hold your left hand stick to the left while clicking OK. I guess I don't really need to explain this now. The main point to note is that you need to have all the sticks centered before you start the program up, not before you start the calibration, before you even start the program. Right, so hold the yaw to the left and click OK. Now it's recognized as yaw and we can see the extents are working properly. Okay, so hold the left hand stick up, right stick to the left, right stick up. So now, oops, well it's disappeared, but now we should see that when we play the program we have some sensible settings working. And it should be doing what we tell it to. It's actually a lot easier to fly this first person view in this game, isn't it? Alright, so after that it's just a matter of setting up your preferred settings to make this feel like your quadcopter actually feels like, and then get practicing, I guess. So I think that's about all I had to explain as far as the FPV game goes. I'm going to switch over to Windows now and perhaps show a little bit of the settings that you need to do to get a gamepad working from this input into a direct input game like most games are on Windows, at least for the Dirt Rally game. I had to do a bit of extra setting up, so I'll switch over to Windows and show you that now.